Hello, dear learners. Welcome to lecture series. I am your assistant professor, Ms. Nila from SNS College of Technology, Coimbatore. Today, in this session, we are going to discuss about the evaluation methods of heat exchangers. So, how the heat exchangers will be evaluated for efficiency. Before getting into the topic, we shall have a brain time. So, I'll give you a riddle. I make fluids flow and currents swirl as the warm ones rises and the cooler ones twirl. What mode of transfer am I? This is my riddle. So find out the answers and give your answers in the comment box. Let's move on to the topic. So here we are going to explore the fundamental methods of understanding and designing heat exchangers, which is also crucial component in various industrial processes. The first one is overall heat transfer coefficient. So the overall heat transfer coefficient qualifies the rate of heat transfer per unit area per temperature difference in a heat exchanger. Okay, so the U, which is heat transfer coefficient, which is denoted as U. The U accounts for combined conduction and convection resistances, including material properties, fluid dynamics, and surface fouling. And the next method is LMTD. So, the log mean temperature difference LMTD method is used when the temperature difference between fluids changes along the heat exchanger's length. It provides an effective average temperature difference for calculations. So the formula we use for LMTD calculation is delta TLM is equal to delta T2 minus delta T1 divided by ln of delta T2 divided by delta T1. Okay, here the delta T1 and delta T2 represents the temperature differences at the two ends of the heat exchanger. The LMTD method, its derivation and application are discussed here. So, the LMTD expression is derived from an energy balance equation on a differential element of the heat exchanger considering varying temperature profiles. So how is its applicability? This method is versatile, applicable to both parallel flow and counterflow heat exchangers, and the efficiency inside. So counterflow configurations generally exhibit a higher LMTD, leading to more efficient heat transfer compared to a parallel flow designs. Okay. Next, heat transfer rate. The heat transfer rate is calculated using the formula Q is equal to UA by delta T LM. The next method is NTU method, which is nothing but number of transfer units. So NTU is a dimensionless parameter including heat exchanger size, which is relative to its heat capacity rate. So what is heat capacity rate? It is a minimum heat capacity rate of the two fluids. So minimum heat capacity which the two fluids can hold on a basic. Next one is effectiveness, which is the ratio of actual to maximum possible heat transfer. So when can we use the NTU method? It is ideal when outlet temperature are unknown and avoiding the iterative nature of the LMTD method. Okay, so the effectiveness of NTU method, how is it calculated? The effectiveness relations are crucial in the NTU method, allowing for heat transfer calculations without knowing the outlet temperatures. So for a counter flow heat exchanger, the given formula is the useful one. for calculation. So these relations are derived from fundamental energy balances and differential equations governing heat exchangers. So the testing of LMTD and NTU methods. So we can compare. So what are the advantages of LMTD and what are the advantages of NTU? For LMTD, it is ideal when all inlet and outlet temperatures are known, allowing direct calculation of heat transfer rate, while for NTU, preferably when outlet temperatures are unknown and simplifying iterative design processes through effectiveness and heat capacity rates. So the assumptions used here is both methods assume steady state operation, constant fluid properties and negligible heat loss to surroundings. So how the complexity flows. So the NTU method can better accommodate complex heat exchanger flow arrangements, often requiring iterative or numerical solutions for LMTD. So in this slide, we have discussed about quantifying performance, LMTD for known temperatures, NTU for design and analysis, practical applications of LMTD and NTU, and choosing the method. So how to choose between the methods. In next video, we can discuss with some other interesting topics. Thank you.